Welcome to the deep dive. Today, we're really taking on something absolutely essential for anyone staring down those high-level aviation theory exams. We're doing a meticulous breakdown of the pressure altimeter. But this isn't just, a quick overview.
Yeah, not at all.
We are isolating the absolute must-know stuff, the high-stakes knowledge, the precise definitions, those tricky mechanical details, and, maybe most importantly, the dangerous atmospheric errors. The ones specifically designed to catch you out in the ATPL exams.
Exactly. The aim is to give you that clarity, the context you need to really master this instrument, turn that dense source material into something crystal clear, something you can actually use.
And that focus is just vital, isn't it?
Yeah.
Because the altimeter, it looks simple, right?
Yeah.
But it's the bedrock of safe vertical navigation.
It really is. It's basically just a reliable pressure gauge, calibrated to show height. But its real job is trying to interpret this incredibly unpredictable atmosphere all through the lens of a fixed theoretical standard.
Okay, let's unpack that core idea straight away. We're measuring height by measuring pressure. How does that physical reality actually turn into a number on a dial that we trust?
Well, it all boils down to the weight of the air column sitting above the aircraft. You see, atmospheric pressure at any given point is determined by the sheer weight of all the air stacked vertically above it, stretching right out to the edge of space.
Right.
So as an aircraft climbs higher, the column of air above it gets shorter. Simple as that. And therefore, the weight of that air decreases.
So higher altitude equals lower pressure. And if you measure that pressure drop, you're effectively measuring how much higher you've gone.
Precisely. We use that pressure decrease as a proxy, a stand-in for vertical movement. But this is where the apparent simplicity ends and the real technical complexity and, frankly, the source of all the potential altimeter errors really begins. Because that relationship, the one between pressure and height, it's emphatically not linear, not even close. Pressure drops really quickly near the surface, but then the drop slows down considerably the higher up you go.
Okay, so it's not a straight line on a graph. That nonlinear reality means you need some clever calibration inside the instrument. But then it gets even more complicated because of external factors. The environment's constantly changing, right?
Absolutely. The instrument has to be built to account for that natural nonlinear drop, sure. But then it also has to somehow deal with two massive variables that constantly mess with the theoretical model. First, you've got huge horizontal pressure differences. Think massive high and low pressure weather systems rolling across the landscape.
Okay.
And second, you have extremely variable temperature and humidity, what we call the lapse rate within the air column itself. These variables mean the altimeter is constantly making a set of assumptions based on a theoretical, perfect standard atmosphere. And reality rarely matches the standard.
Which immediately brings us to vocabulary. And, in that exam room, getting these foundational definitions absolutely spot on is non-negotiable. If you mix these up, you're almost guaranteed to trip up on those multiple choice questions designed around these, subtle differences.
Let's nail these down right now. We start with the most general term, height. Height is simply the vertical distance of any level, point, or object measured from a specified datum. And that datum, honestly, it could be anything you choose for convenience, a runway threshold, the parking apron, maybe a local obstacle like a radio mast.
But aviation needs a common global reference point, which is where mean sea level MSL comes into play.
Yes. And from MSL, we get two absolutely crucial operational terms. First one, elevation. Elevation refers to the vertical distance of a fixed point or object. Think an aerodrome, a mountain peak, a navigation beacon measured specifically from MSL. It doesn't move. It's static.
Got it. Fixed point, MSL. That's elevation. And the second term?
That's altitude. Altitude is like elevation's twin, but it refers to the vertical distance of a movable object, which for us is the aircraft itself measured from MSL. So when we talk about flight altitude, what we really mean is feet above mean sea level.
Okay, clear. Now let's get into the critical reference altitudes. The whole global aviation system is built around one single standardized pressure setting, and that gives us pressure altitude.
That's right. Pressure.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best